Hello, today we're going to talk about solving systems of linear equations using addition. Alright, so we've already done graphing to solve systems, and we've done the substitution method to solve systems. This is just another method where you get rid of one variable just like we did basically substitution. Whereas if we did substitution here, we would, since they're both equal to y, we would just make this x plus y equals negative x plus 3. All right, and we'd solve from there. Now that's not what we're going to do here. All right, here with the addition method, we're going to combine them together. All right, now it's a little tricky, it can be tricky, but this is set up for it. So you look at your variables. I have a y and an x, and a y and a negative x. So if I added these together, what would happen? All right, so 1y plus 1y would give me 2y equals x minus x would give me 0. 1 plus 3 would give me 4. So now I am down to my one variable that I wanted to be at. Just like up here with substitution, I just have my x's. Now I just have my y's. And this is what the addition method does, is it combines the two together when you have the inverse of one of the variables. What the inverse is like for here I have x and negative x. Or it could be 2x and negative 2x. Or y and negative y. Or negative 4y and 4y. Those are called inverses. They're the exact opposites. And when you add all of them together, you get 0. And it gets rid of it. So that's what we're doing here. We're combining them together so that we only have one variable left, and then we can solve. So our y here equals 2. Now the second part of this is exactly like what we did with substitution. We solved for one variable, and then we plugged it in. And that's what we're going to do here. We're going to plug this in to the equation. Let me use it as a color. So I have my x equals my y equals. I know my y equals 2. So now I'm going to plug it back in I plug it in for both just to check myself. You don't have to plug it into both equations, but just a suggestion. So I plug in my 2 here, so 2 equals x plus 1. So subtract the 1 over, because I'm solving for x. So 1 equals x. Now if I get 1 over here, I'm all good. Negative 1. I have a negative in front of the x, so I divide by negative 1. And x equals 1. Alright? So that's my point. So these are consistent equations that cross at the point 1, 2. So 1, 2 will work for both of these equations. That is its solution. That's how you use the addition method. We're going to do 2 more examples of different types that you'll see, but this is the most basic one where you already have it set up where the inverses are. Alright, now for example number 2. So with the first one, we had something like this. Alright, where we already had the inverse set up. Sometimes your inverse won't be set up. Alright, and you have to make it to where you have an inverse. In this case, you have to multiply one of the equations by something, everything. So, what can I multiply? And I'm going to do the y here. I like to do, if it doesn't have a coefficient in front of it, that's a 2 and a 3. I like to do the one that has the same coefficient because it makes it easier. So, how would I make this y the inverse of this y? So I want to make this one negative y. How would I do that? Well, I'd multiply it by a negative. But if I multiply one of the parts by a negative, I have to multiply everything in that equation by negative 1. So multiply that by negative 1 and get negative y. Then multiply negative 1 times negative 3 and get positive 3. Then negative 1 times 1 gives me negative 1. Then I just bring the other equation over. Now, I add them together. Y minus y is 0. 2x plus 3x is 5x. Negative 4 minus 1 is negative 5. And now I just solve. Plus 5, 5 equals 5x. Divide by 5, divide by 5, x equals 1. Alright, I'm gonna come back over here. So I know my x equals 1, but I need to know what my y equals now because I need the point. So I'm gonna plug x equals 1 back into both of my original equations. So y equals 2x minus 4, and y equals negative 3x plus 1. So y equals 2 times 1 minus 4. Y equals 2 minus 4. Y equals negative 2. Here, I plug the 1 in there. So y equals negative 3 times 1 plus 1. Y equals negative 3 plus 1. Y equals negative 2. Negative 2, negative 2. There we go. So my answer here is 1, negative 2. So these are consistent equations that cross at the point 1, negative 2. So if I plug 1, negative 2 into both of these, they both work out. And that is our solution for this set of systems of linear equations by using addition. All right, then, now this is our third example. So the first one we did was completely set up the right way, where the inverses were already there. Our next one looks something like this, where there was no inverses. And we had to make one. So this was set up already. This we had to make an inverse. Now this one, all right? Before we can make it an inverse, or even see if we do, we have to make them look the same. You can't add or subtract them if they look like that. Now this one is set up for a good substitution if you want to do substitution. Now again, I say this in the meetings and everything, whichever one of these methods you like the best, I would use. But that's just me. I like substitution the best. Some people like this the best. Some people like graphing the best. It's just a personal preference. So I'm going to take this one and make it look like that. I'm actually going to do it down here. So I need the x on this side. So to make it look like that, I subtract the x from both sides, and I get negative x plus y equals negative 4. So 3x minus y equals 6. I'm going to just put this up there. All right. So now, do I have inverses? Yes, I do. So we're already set up for it. So now we can just add them. We don't have to make any of them an inverse. So draw the line underneath. 3x minus x gives me 2x. This gives me 0. And 6 minus 4 gives me 2. So 2x equals 2. Divide by 2, x equals 1. Let me make sure. Good. All right, now we have to find our y. So I'm going to plug it back into both the original equations. So my x equals, my y equals. So my x equals 1, need to find my y. Both my original equations. 3 times 1 minus y equals 6. Negative y equals 3. Negative 3. And there you go. So our answer is 1, negative 3. And there you go. That is our answer. It is consistent. It is not equivalent equations or inconsistent. They're not parallel lines, nothing like that. All right. So now I've shown you all 3 ways. When it's set up, when you have to make it, and then when you have to switch the equation first, and then do what you need to do. All right, this has been Solving Systems of Linear Equations Using Addition. Hope it helps. Good luck.